Hi everyone, I'm Liz.
Hi, I'm Jingmei. So our activity pertains to 6th and 7th grade geometry. We're going to use parallel lines cut by a transversal to introduce 3 geometric concepts: vertical angles, alternate exterior and interior angles, as well as corresponding angles. This is under the assumption that the students have learned complementary angles as well as supplementary angles. We first will use mathematical reasoning and calculation to prove and introduce these angles, and later we'll be using the software GDE softwares to prove and support these concepts.
Jingmei and I decided to do this lesson because we think that these concepts, all relating to congruence, really provide the foundation for students' geometric understanding. And this understanding will come back again and again as students progress in their mathematical career and further on down the road when they run into Euclidean geometry. We also worked together to create a DGE file that really helps enhance students' understandings of those 3 geometric concepts, and hopefully will help them prove that some relationships between those congruent angles.
So let's look at our graph right now. Hopefully you guys will be able to see somewhat the dots and the labels and the angles here, but there is a given value of an angle, which is CBF at angle 140. What we're going to ask students to do is, using supplement angles, we're going to try to ask them to obtain the angle measure of CBQ. And using the same idea, same method, we also going to ask them to obtain the measure of FBI. If things go well, they will be able to see that the angles for QBC and FBI are both 40 degrees. So at this point, we're going to tell them the congruency and give them the terms for this pair of angles, which is vertical angles. And furthermore, we're also going to ask them, among these angles right here, to identify another pair of vertical angles. And continue on, we are going to ask them and introduce them the concept of alternate interior angles, which is BFG and IBF. Since we have already obtained the measure of angle IBF, we're now gonna show them that the angle of BFG is also congruent. But in order to do that, we're not gonna use mathematical reasoning to show that. Rather, we're gonna use the software to support the congruency at this point. And Liz will show how we designed that.
So when we understood that angle IBF or FBI is an angle measure of 40 degrees, we asked students if there was a way to create a tool that would consistently represent that measure of 40 degrees. And students came up with a triangle. So we created a triangle. And we created a triangle such that angle measure T will always remain 40 degrees. We did that by creating 2 points labeled T and labeled U. We then selected point T as the point of rotation, and we rotated point U 40 degrees. When we did that, we did, in essence, create a triangle that will always have an angle measure of 40 degrees at angle T. Now, this is a static representation of our Sketchpad document. In the DGE environment, you would be able to manipulate and move this triangle. It can be rotated, it can be resized, bigger, smaller, but every single time that happens and you make an adjustment to it, this angle will always remain the same. Angle T will always be that 40 degrees. We can then use that to help us assess whether or not angle FBI is the same angle measure as angle BFG. We would do that by manipulating and moving the triangle down here, connecting point T to point F, and then moving the other points so that the triangle, Mr. T, fits directly inside without overlapping and without any additional white space.
So we believe that with this little tool, we'll really get students interested in using DGI to prove and support the finding. So I think this is a valuable tool we thought would be really students would like. So,
not to mention that we actually had quite a bit of fun manipulating the triangle over and over again ourselves.
And this hasn't been done in class, in Dr. Gabby's class, so we're excited. So anyway, continue on. Now we have proved the congruency of these two angles. We can now expand onto the ideas of corresponding angles. From this point, after we have made sure that students have clearly understood these three angles, we are going to have them identify all the remaining angles and see their congruency, identify pairs of vertical, alternate exterior and interior angles, as well as the corresponding angles.
Absolutely. So while students are engaging in this exploration, Jingmei and I would be walking around asking students questions, following up with them about the pairs that they have identified as congruent. And from there, Jingmei will express to you what we believe about this process in terms of its cognitive demand.
Bear in mind, these are students of 6th and 7th grade. It might seem rather straightforward to us, but I think it will be somewhat challenging for them to identify the congruency of various angles. So we think that is of a little higher cognitive, instead of just straightforward subtraction and addition of the supplement angles. Further on, to attend to the needs of higher cognitive demand, we also create a perpendicular line right here to this line right here, and mark the right angle right here. Using what we will ask the student to use and utilize what they have learned so far of vertical, alternate, and corresponding angles to try to obtain the angle measure of little x right here. You might not be able to see it, but we will want them to obtain the angles right here. And we thought that is in the realm of higher cognitive demand task.
We also think that on the whole, the way that we've set up the lessons into 3 different phases, we've really met the needs of all of our students, and we've allowed those who are very either visual learners or who are quick on their feet, who can figure all of the angle measures out, identify the corresponding alternate interior and vertical angles with ease. We've then moved on and provided them with an additional task. For those students who may be struggling, and again, this is a brand new concept, and so it is not as readily apparent to 6th and 7th graders as it is to us. We've allowed them opportunities to maybe isolate a set of the angles that we're talking about. It may mean that we spend considerable time with a student discussing alternate interior angles and identifying the pairs of alternate interior angles represented within this diagram. It may mean that we spend additional time working on those individual skills. But for those who are ready to move right along, the second page of our document asks students to create an example of two parallel lines cut by a transversal, which again asks them to activate that prior knowledge of constructing parallel lines within Sketchpad, as well as how to go about and create a transversal. And then on their own document, we are asking them to demonstrate, to show us where their corresponding angles are, where the alternate interior, or perhaps, depending on the complexity of the figure, the alternate exterior angles are located, as well as the corresponding angles. Once they've completed that task, we would then ask them to create essentially a non-example to reinforce what happens, or that all of these relationships are dependent upon that parallel line construction. So in the second part of page 2, phase 2, we would ask students to create a Sketchpad file that has two lines that are then cut by a transversal. The lines may not be parallel. And then to discuss and explain what then happens with all of these previously identified angle relationships and how that changes everything. So again, an example and a non-example.
And we also like this design because we realize that we can also use the other features of the software to tap into other geometric concepts as well. For instance, the sum of interior angles of a polygon, we can introduce the software feature where we incorporate the measure using the calculation and introduce them the ideas of the sum of interior angles of the polygon, which is related to our third activity of our design, which we believe is of the highest cognitive demand of the whole lesson plan. So I will briefly explain the whole activity. It won't take too long, but just to show this is attend to the higher cognitive demand task. So the given measure at the very far left of the graph is given right here. And there's some known values that are also given right here. What we ask students is to utilize so far what they have learned of vertical, alternate, and corresponding angles to try to obtain the angles right here, over there. So it's from left all the way to the right. It will be a very interesting task along the way, how they will organize their procedures in obtaining the angles. So we think is a very interesting task.
Absolutely, and we think that the material is engaging. Again, a lot of it is student directed. Students deciding which angles to attend to initially. Students creating DGE files, that support their understanding, which will then allow the two of us to go around the room and to constantly be assessing where our students are at, and then redirecting, or perhaps in some cases reteaching these concepts that we've mentioned today. So we had a lot of fun creating these. We've had some fun, perhaps a little more nerves actually carrying out this video presentation. We hope you've enjoyed it, and
we enjoyed it. We really love the software feature of this activity, and we think students will love it as well.
It's true. Thank you so much for following along with us, and we'll see you in class.